All right, now let's take another look at an example on seeing how we can use forces and work to solve a problem. So let's say we have a car and it's moving with some initial velocity v. Okay, and let's say you know we're eventually we know that this car is going to come to a stop, right? So let's say we ignore all the friction on it between its the axles and its wheels in the car and everything. So we take all of that out. So we say that the only thing that's really stopping the car is going to be a drag force, right? So we have some drag force acting on it. Okay, and so we know that eventually that force is going to bring it to a stop, and it's going to stop some distance x later. So the question is, can we find x? All right. So we know that our initial energy is 1/2 the mass of the car times its velocity squared. We know that its final energy is 0. It's all kinetic energy. And so what that's telling us, again, is that the initial energy plus the work done is equal to 0. Well, so that means we know that the work is going to be less than 0, right? So we know that the work is going to be minus 1/2 mv squared. And this is equal to the integral of f dx. We're going to say, to a good approximation for this problem, that the drag force is basically constant. This isn't actually true. It's actually dependent on the velocity that you're moving. But let's say that it's constant, just to make this easier. So we'll say that there's a constant force slowing it down, which means this is just going to be f times x, f of d times x, but with a minus sign, right? Because I'm doing work against the direction that we're traveling, right? Because we know that overall that this is going to give us a negative work. So in other words, we say the drag force times x is equal to 1/2 mv squared. So x is equal to mv squared over 2 times the drag force. So this is just an example of how you can use work to solve a problem. And so your book has a lot of so your book doesn't necessarily have these problems, right? Because your book doesn't really go into this relationship between work and energy. So to work these problems, I really recommend doing a lot of the problems in like Halliday, Resnick, Walker, that's on reserve in the library, or some of the Giancoli problems, because both the textbook and its solutions manual are on reserve in the POA library. So keep that in mind before you go to take this exam, that there are going to be some questions on it that aren't in your book, because not all of the material is covered in your textbook. But I think these are important things to learn that you'd get in most physics classes. So I think so definitely make sure you work some problems in there before you take the first exam, before you take your work exam.